Find a possible solution for f of x, given that f of x is the integral of 2 to the negative x. Okay? So first thought is power rule. Nope, doesn't work, because if you saw something like x squared, then be like, oh yeah, power rule, no big deal. Something like substitution is like, not really. When you see like a number to, when you see x as an exponent, there's kind of a trick that you do. And I hate saying trick. It sounds like, oh, there's a magical something special for, it's like, no, it's not that. But there is a certain method which works most of the time. And the way it is we'll start by, we'll rewrite this. We'll say, all right, this is the same as, I'm going to leave off the integral for now, just to show how we can rewrite 2 to the negative x. So we'll say this is the same as e to the natural log of 2 to e to the negative x. And you're like, wow, that's kind of cumbersome. It is. But we can use log rules, some rules applying to logs. I like to refer to this rule as log rolling, because if you're imagine this negative x exponent up here as a log, whoop, and then it rolls down to there. Completely legitimate. Okay, so now we're left with this. And this we can actually take the derivative of. Well, I guess we could take the derivative of this as well, but this is more straightforward for us. This is kind of this is going to be a substitution. So I'm going to rewrite things real quick. So this 2 to the negative x is equal to e to the negative x natural log of 2 dx, where natural log of 2 is just a constant. And so what we're going to do then is u equals negative x natural log of 2. Du then is negative natural log of 2 dx. And we have 1 over negative natural log of 2 equals dx. Okay? So then rewriting this, we have integral e to the, wait a sec, negative x, u. And then dx becomes, oh, so see a little du in there. Du 1 over negative natural log of 2. Take the integral, we have e to the u over natural log of 2 negative. And this will then equal e to the negative x natural log of 2 all over negative natural log of 2. I know it feels like a billion steps here. It's not actually a billion, but it is many. And we'll do a couple more steps, just kind of backtrack the way we came. And we have, let's see, e to the natural log of 2 to the negative x over natural log of 2. The e and natural log cancel. By cancel, I mean they kind of, yeah, I'll say the word cancel. Natural log of 2. And that should actually be our final answer. And then there's going to be a plus c, but I'll worry about that in a sec. And so now we just got to find out, hopefully this matches up to one of our answers. So it looks kind of like, aha, so it's going to be this one. Nope, there we go. This one right here. And the difference here then you see is this natural log of 1/2. There's natural log of 2 in the bottom. So if we use our log rolling rule, this could become natural log of 2 to the negative 1, which is the same as natural log of 1/2. Just means that 2 is on the bottom then. So this is actually the same answer as this one here. So to backtrack real quick, we saw that we had, all right, we had a constant to an exponent. And the way we're going to have to deal with that is we do e to the natural log. You can always do e to the natural log of anything. There are 2 things you can always do in math. Really 3, this is the third one. You can always add 0, multiply by 1, or do e to the natural log of something. So the add 0 would be like you have x plus 2 minus 2, added 0. Have x, multiply by 3, divide by 3. And then the last one, which I said there's 2 rules, there's 3, we use 3, would be x then becomes e to the natural log of x. And this is the rule that we used to rearrange things so we could do a substitution on this problem. This was actually fairly difficult. You can look up a log rule to basically, this will play out pretty much the same every time, and you can look up what the integral of 2 to the x, or a constant to the x is, and you can memorize it. I prefer not to memorize it just because it's uncommon enough that you're better off just working through it. Every time I memorize something, I forget it, or I make a mistake. And so the way I minimize mistakes for this is I just work through it. That's how you solve this problem. Thank you much, and see you next time.